Hello friends, welcome to Risingpearl.com. Today we are talking about series 3 trigonometry. This is webisode number 15 and today we are going to learn solving problems related to trigonometric ratios of some specific angles. This is part 2. In webisode 14, the last webisode, we started this series, this part 1, where we started taking a look at what kind of questions we may be expecting on this particular topic. So now, what are these specific angles, or also some important angles, or also some standard angles? So these are the angles. So 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. We want to make sure that we know the 6 trigonometric ratios for each of these angles. So sine 0 degree, 30 degree, 45 degree, 60 degree, 90 degree. Similarly cos, all these. We would want to always know each of these 6 ratios for each of these angles. It's very, very important. We have spent enough time in the last few episodes to go over this. Now again, just to quickly recap, the box that we have highlighted here, at the very minimum, you definitely want to memorize and remember these ratios, sine, cos, and tan for these angles. Then cosec, sec, and cot are simply the reciprocal of sine, cos, and tan respectively. Right? Let's continue to find out what are some of the other questions that you may be getting and how we can solve them. So question number 5, because this is a continuation from our last webisode, part 1. So let's take a look at what kind of question is this. This is a multiple choice question. Choose sine 2a equals 2 times sine a is true when a equals to which values. So what is given is that we have a statement which is given. So for which value of a is of course an angle, because all the choices are angle. So for which value of a this statement is true. One just quick observation, as you can see, this is kind of a little unusual because so far we have been seeing sine of an angle, right? So sine of an angle, and that is a ratio. So here, instead of giving an angle, we have 2 times a. What is important to simply understand is that even though it is expressed in this kind of a strange form, it just means sine of an angle. In other words, think this way. You can have sine 60 degrees, which we know. You could have written sine 60 degrees as 2 times 30 degrees. So, which is essentially the same as sine 60 degrees. So, just wanting to make sure that sine 2a is nothing but sine of an angle, any angle, right? So that is what just to keep in mind. So again, coming back to the question, how are we going to solve questions like this? Well, the only way to solve these type of questions is that you have to evaluate each choice one by one and find out for which choice the left hand side and the right hand side both values are same. So the moment you find out that particular choice, that will be the answer. So let's start out for the 0 degrees. Let's see, for 0 degrees, so the left hand side is equal to sine 2a. Sine 2a. So if a equals to 0, then it will be sine 2 times 0, which is equal to sine 0 degrees. And we know that sine 0 degrees is actually 0. Right? Now what about the right hand side? Remember, we have to look at each value and we have to evaluate what is the value for left hand side for that angle and what is the value for right hand side. So right hand side expression is 2 times sine a. So sine, again, if a is 0, this is 0 degrees. So we have 2 times sine 0 degrees is 0, or 2 times 0 is 0. Wow, so here we have noticed that for a equal to 0 degrees, both the left hand side and the right hand side, they are same. Right? So we just got lucky that for a equal to 0 degrees, this expression actually is true because we have left hand side equal to right hand side, and hence this is our answer. So at this point there is no need for us to evaluate the other ones. Of course, if you have more time, you want to make sure that you are not making any calculation mistake, and then you can still evaluate each one of them, left hand side, right hand side, and make sure that for none of the other values you get both left hand side equal to right hand side. But if you're pretty sure about your calculation, like we just finished here, we are pretty sure that choice A is the answer. Let's move on and take a look at the next question. Now, question number 6. If tan A plus B equals square root 3 and tan A minus B equals 1 divided by square root 3, and also A plus B is greater than 0 degrees but less than equal to 90 degrees, and also A greater than B, find A and B. At the surface, this looks like one really complicated question because normally we are used to tan of an angle, right? We are not used to seeing an expression here. We have been looking at tan of an angle, right? Similarly, here also you have another expression. Here you have tan of another expression, and if this was expression 1, this is like a expression 2. So two different things are given. Clearly they are related because this is also expressed in terms of A and B, and this expression is also expressed in terms of A and B. But so how are we going to handle a question like this? Well, what we would want to do is, first of all, for the time being, ignore this part. We are not going to focus on this part for the time being. So what we will think is that, well, we know tan of some angle is equal to square root 3. This is what is given. We are going to assume this is x, right? And for this one, we are going to assume that tan of some other angle, and we'll call it y, is given as 1 by square root 3. This is the first and foremost thing that we have to understand. That means here this expression A plus B, I am replacing that as x. That means that x is equal to x plus b, and here y is equal to A minus b. So whatever the value of this is, because it is complicated, I'm going to just replace that by one variable, call that x. Similarly here, I'm going to replace whatever this expression is by one variable, call it y. Please note that x and y must be two different values. Why? Because we have an expression A plus b, whatever the value of A and b is, and here it is A minus b. So we cannot put x and x in both cases, and we cannot put y and y in both cases. This expression, whatever this is going to be different from this expression, right? If A and b are two different values, then these two expressions will be different. So one, let's take this as y, x. For the other one, let's take this as y. Now that we have just written this, now let's just go ahead and it'll help us simple. Let's clean this up a little bit. So what we have here is that we have tan of x equal to square root 3, and we have tan of y equal to 1 by square root 3, where x is equal to A plus b and y is equal to A minus b. Now we are going to focus on this. Now x is A plus b, right? And it is given that this is actually an acute angle. So it is more than 0 degrees and it is less than equal to 90 degrees. So for what acute angle is tan of that angle square root 3? So here we have to now scan through all of the acute angles, the standard angles or those important angles. So 0 degree, so we have to think Now tan 0 degrees is 0. Tan 30 degrees is 1 by square root 3. Tan 45 degrees is equal to 1. Tan 60 degree is equal to square root 3. And then tan 90 degrees is equal to undefined or not defined. Now this we know from the table. We know these values. So because x or this is an acute angle, we are trying to find out for what angle, and we are specifically scanning for 0 degree, 30 degree, 45 degree, 60 degree and 90 degree because these are the only ones we know. So for which value is, and they are all acute angles, is tan x square root 3, and the answer is it is 60 degrees. So when tan 60 degree, the value is square root 3. That means that x is equal to 60. X is 60 degrees. Again, it's important to understand that because we have condensed this expression into one variable, so tan of that angle is square root 3, and if this is an acute angle, so which angle can it be? So this angle must be 60 degrees because tan 60 degrees square root 3. So we have x is equal to 60 degrees, right? Similarly, tan of what angle is 1 by square root 3? That is 30 degrees. So y must be 30 degrees. So now what is x? And now that we know x is this and y is this, we are going to substitute that in these two equations. So we have a plus b equal to 60 degrees, and we have a minus b equal to 30 degrees. So at this point you have two equations and two variables. So using either the substitution or any other way, you are just going to solve two equations. Two equations are given and two variables are unknown. So we can actually solve two equations with two variables. So if you were to simply add these two, right? So you will get 2 times a, b and b will cancel, is equal to 60 plus 30, that will be 90 degrees. So you will get a equal to 90 by 2 or equal to 45 degrees. So a is equal to 45 degrees. Now then what is the value of b? You can put that in any one of these equations. So if a is 45 degrees, so b is 60 minus a, and if a is 45 degrees, 60 minus 45 is equal to 15 degrees. So we have b is equal to 15 degrees. So, and this also satisfies the final criteria that a is greater than b. So friends, we have a, let's write it here. I know that this has become really too much of write-up has gone in here, but I hope you are following us along and you are able to understand. If not, please feel free to share your comments and feedback and ask questions. I'll be more than happy to explain that to you. So a equals 45 degrees and b equals 15 degrees. So this will be our final answer. So our question actually wanted us to find out the value of a and b. So this is how we are going to handle this kind of questions. Because this got as complicated as it did, let's take one final question of similar format and try to solve it before we wrap up this presentation. If sine of some expression is equal to 1 by 2 and cos of some other expression is 1 by 2, please note that here this is a sine ratio and this is a cos ratio, and a plus b is an acute angle between 0 and 90 degrees, and a greater than b, we need to find out the value of a and b. So let's write what value of sine, so again, so here we are going to say, let's say a minus b. Instead of having two unknowns, let's replace the two unknowns by one unknown. Let's call that x. And similarly for a plus b, let us replace these two unknowns by another unknown, but one unknown, y. So what we have is, we have sine a minus b, we are going to call it x. Sine of x, x is some angle, this is 1 by 2. And cos of some angle, we are calling it y, is 1 by 2. And x, we don't know about y, but x is a, if you add these two, it's a acute angle. Obviously if you add them, if it is an acute angle, if you subtract them, it will definitely be another acute angle. So what are the angles? Again, our standard angles are 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. So for which of these angles sine is 1 by 2? And yes, it is for this particular angle. So sine 30 degrees is equal to 1 by 2. So we have sine x equal to 1 by 2. So x must be equal to 30 degrees. So from here we say x is equal to 30 degrees. Now similarly for here, we again have the same set of angles, but now we have to evaluate cos of which angles is 1 by 2. This is important. For this equation, it is not sine. In the last question, both of the equations were tan and tan. Here we have a sine and we have a cos. So when we evaluate this expression, this equation, we have to evaluate cos of which angle is 1 by 2. So cos 0, cos 60, cos 45, cos 60. So cos 60 degrees is actually 1 by 2. And since we have cos y equal to 1 by 2, that means y must be equal to 60. So we have x equals to 30 and y equals to 60. So now let's solve this. So what we have is, we have x equals to 30 degrees and we have y equal to 60 degrees. And what is x? X is nothing but a minus b, and y is nothing but a plus b. So again friends, here we have equation 1, equation 2. So we have two equations and two variables, a and b. So we can solve them either by elimination or substitution. And so if you were to just simply add these two, so plus b minus b will cancel out. So you will get 2 times a equals to 30 plus 60, which will be 90. And then a will be equal to 90 divided by 2, or 45 degrees. Similarly, now that you have we have found out a equal to 45 degrees, we can put that in any one of the equation to find out the value of b. So let's say we put it in this equation. So if you put a equal to 45 here, then we will have 45 minus b is equal to 30 degrees. 30 degrees, or we take b on the other side and get 30 over here, or b will be equal to 45 minus 30, which will be 15 degrees. So a is 45 degrees and b is 15 degrees. So this is how, friends, you are going to solve these kind of questions where the trigonometric ratio is not directly given as an angle, but it is given as an expression of angles, right? So you are going to try to reduce or condense that expression into one variable and then try to find out for what angle what is the value of that one variable, right? So in this case, again, we said this was x and this was y. Then it was our goal to find out what is that value of x for which this statement is true, and the same for y. And after we have found out this, then we can get the two equations and two variables, and then we can actually solve them using either the method of elimination or method of substitution, and then find out the values of each of the angles. So friends, these are a little bit more difficult, challenging questions. If you have any questions, comments on how to solve these problems, feel free to let us know, and I'll be more than happy to provide more further clarification.